Hi, Jimmy. How are you?
I'm fine.
How was your day this morning?
Okay.
What do you do this morning?
Study and yeah.
Managed to go over the question yesterday?
Not really channel, some only.
Okay, if not, then we will spend time doing it together rather than go to a new topic. Okay, we can got the time, go and do checkpoint. Those that we have not completed.
Yeah, Che, I think I'm going to start watching your video. Che, you posted quite a lot, right?
Yeah, I posted all the notes in the YouTube. All you need to do is whatever you
like got around 80 videos here.
say again.
80 videos.
It's easy to download from YouTube. Even some
Yeah,
of the
no, it's easier to watch in YouTube. Yeah, it's easier to watch in YouTube.
Easy to watch on YouTube. In fact, some of your teacher also posted that. Now, some of those teaching physics, I saw them posted there also. So if you want, you can also look at them.
No, very useful one, Che, yeah. Yours. Oh yeah, I got I counted how many days left I got for exam. I got 61 days left.
61 days. So it's better to do something about it. They still got no question to ask. You should be asking your second term question already. And you're still not asking anything. Okay, let us divide into two, about half an
I
hour
need to watch
session.
the video first, then I can ask lah. So,
You have been asking too long already. Going to watch video, and you still haven't asked the second term yet. So I'm very worried for you. You have to listen and then do the homework. If you don't know how to solve the question, you will definitely have problem in your exam.
Then ask you later if I don't understand.
Yeah, you can ask. You haven't been asking at all. Let's go to objective question. Focus 23. Right, as I say, these are all the things that you need to remember. Okay, all this for this topic. Okay, a glass surface of refractive index 1.67 is coated with a film of refractive index 1.55. What is the minimum thickness of the film so that the light of wavelength 540 nanometer is not reflected from the glass? Right? This is anti-reflective coating, non-reflective coating. What is the answer? First, remember the question, remember the formula. If not derive it, it doesn't take a long time. Yep. Should be able to do, refer to your note. You should have a exercise book or foolscap paper. I think we have been solving this for you in class. So now refer to your note. Can or not?
C.
What's the answer?
C.
C. Okay. The path length T times your refractive index. That's why it's 2T. Then path length is lambda over 2 for destructive interference. Okay. If you can remember the formula, go ahead. If not, derive it. No. B. Okay. Where did you go wrong? Yep. Use the wrong formula. Where did you go wrong?
I used the wrong formula.
It's just very easy to remember. You can remember. If not, this is T. This is T. So 2T. 2T times your reflective index of the film. That's all. And then you want destructive lambda over 2. That's all. This one, two polarizer P1, P2 arranged coaxially with the polarizing axis parallel. A beam of unpolarized light of intensity I0, this is I0 here, is directed to P1 as shown in the figure. To what angle the polarizer P2, this one, must be rotated about the common axis so that the intensity of beam that emerges is 0.2 I0. Okay, what's the answer?
Boy.
Let us see. I0 coming in. Right? Always remember, it doesn't matter about the axis. You will always cut off half of them. So it will be I1. So I1 will be just your I0 over 2. Then after that, you have to use Mahler's law. Right? You want to find I2. So I1 is half of I naught. Then your I2 is just your I1 cos squared theta, Mahler's law. Then replace the this I1. That is half I naught, put it in there. Then you want the intensity of the beam. So you are interested in I2 and I1. So you are given this fraction I2, or you can take I1 you can straight away place this is this I2, this one equals to 0.2 I naught. If not, take the I naught down. Same thing, I naught down, I2 over I naught. Right, I2 over I naught, or I2 over I1, same thing. What am I doing? I2, you want I2 over I1. Why didn't I do straight away do that? Why when I do funny thing here? I take I2 over I1, I take square root, I get that's what I get. Then I2, okay, I simplify the step. I2 is this value. Then I1 is half I naught. So the half, the 2 becomes on top. I naught and I naught cancel off. Can see or not? If not, I show you. Can understand? Go and do funny thing. Okay, we cannot let us let me just show you. I2, this I2. Zero point two I naught. Then I1 is half is I naught or 2. That's all. Do anything illegal. Just you have to do it. I do it. Assume that you can do it mentally. Stroke 2. Can? I not cancel off. Right? I take I2 over I1 because I2 is given. I1 I've already calculated that. So I2 is 0.2 I naught, and I1 is just half I naught. So I naught and I naught cancel off. I'm still here. I get that. Then use calculator. Yep. Anything that's not clear? Yep. Talk to me. Anything that's not clear? You can use this one. Use this one. If you want to, I use these 2 equations, that's all. Okay, now, anything which part not clear? Yeah, talk to me. Which part you don't not clear? If you are okay, let's go to the next question. Don't need all that. Okay now, okay now. What's the problem? Talk to me, talk to me. If you have problem, let me know. What is the problem? I can explain again.
Okay.
Okay, if it's okay, let's go to number 3. The figure shows two parallel rays, PQ and XY, where the geometrical distance PQ equals to XY. The ray PQ passes through a piece of glass of thickness 1.2 cm and refractive index 1.5. What is the optical path difference between the two rays? Okay, what's the answer? Yeah, what's the answer?
Boy.
Let us see. Optical path difference. It has thickness D. And right, this one I subtract the 2 already. That's why I got this one. That's the optical path difference. Basically, this one travel the same distance as that one, but this one has to go through here. So it's n minus 1t. Okay, why? Good. Okay. Any comment? Any comment? Any comment? Anything not clear? You got it right, this one? Good. So if no comment, then I'll go to the next question. Why I give you the answer? Okay, since I give you the answer, I just explain to you. The figure shows the arrangement in a Young double slit experiment. The interference fringes are formed on the screen. The center maximum is at O, that's the center maximum. The first maximum at P, first maximum. Sorry, first minimum at P. And the first maximum at Q. That's maximum, this minimum, this 0, the maxima, the central maxima. Which row correctly gives the phase difference between light rays from S1 and S2 at P and Q? Okay, at P, the path difference, at P, the path difference is what? Yeah, at P, what is the path difference?
Pi.
Path different, did not phase different.
Donald chưa?
That's why you are just guessing because I show you the answer. The path difference is half lambda. You want destructive interference, the first one is lambda over 2. Then this one is lambda. Then convert to phase difference. Right? Lambda equals to 2 pi. So half lambda equals to pi. Right? Q is not 0, it's 2 pi. Okay. Donkey. At P, we actually have to work with at P, the path difference is try to simplify, but you have to reason it out step by step. Okay, whereas at Q, at P, the path difference is half lambda. What is happening? Which is phase difference of pi radian. Okay. Same at Q. Need to explain a little bit. At Q, the path difference is lambda, which is a phase difference of pi. Okay, 2 pi. Anything not clear? Yep. Anything not clear? Anything you want to ask? Let me just switch on the switch.
So that means the difference between P and Q is half lambda, is it?
Say again.
The difference, they just say like they want to compare P and Q. So the difference between them is half lambda, right? Also.
For P, right, the path difference is S2P minus S1P. If it is the first destructive is half lambda. Then half lambda, you must remember, lambda equals to 2 pi radian. So pi radian is half lambda. No? Yeah. Yeah, studied very earlier, much earlier, 2 pi radian. Yeah, whatever is not con. You are not remembering everything I teach you. That's why you are struggling to understand what I'm teaching you. It doesn't help you if you don't want to do homework. I think this is under wave motion. Where is the phase different? Phase different, phase different. There. All right. 0. If we look at period, this is a quarter period. This is a half the period. So a quarter period is equal to 90 degrees. Our period is 180. You do in terms of angle, that's in terms of phase angle. Right? We use 5 over 2 pi. Is 5 over 2 pi is the period. And then anytime you want, we just calculate that. Right? Same thing. We are just using, we are just using phase is over 2 pi is x over lambda. 2 pi is lambda. And then x is correspond to, instead of x, you can have your phi there. Okay, now can remember or not? Come on, talk to me. You are very quiet. I don't know how to help you today. Whatever you don't understand, you better ask. I'm just reviewing.
Understand.
Understand. You are using this formula. This formula. Right? So I didn't show it to you there. Okay. How about this one? Monochromatic light of wavelength 630 nanometer is at normal incidence on 2 slit system with a separation of 0.35 millimeter. What is the angle between the second order and the 0th order maxima? This one I also have to learn myself, because when I teach a student, we only find the separation, the fringe separation only. Yep, what's the answer? You have to find the fringe separation first. Refer to your note. Refer to your note. If you have faithfully written your note down, you should be able to refer to it and calculate out. Yep, what's the answer? Yeah, xm is m lambda d times your d, and your 2 is the second order, so m equals to 2. Right? Second order, the path difference is lambda. Arc length, s equals to r theta. So the angle is s divided by r. Okay. S, right? S is that one. Okay, you put your, sorry. How come I didn't use any diagram to help you? Let me see whether I can get a diagram or not. Why didn't I use a diagram? Let me see whether I can get a diagram or not. Help you to imagine. Physics require a lot of imagination. What am I doing? Okay, let's try to use this diagram. Remove all that. Okay. There's your XM. There's your D. Right? Remember your D is very large. So your XM, the SS is your XM, and R is your D. Then after that, I go back to here. Okay, I think I have done something wrong here. Should I should have written it down? Trying to simplify too much. Okay, put in your value. M is 2, lambda or D. What am I doing? What am I doing? What am I doing? What am I doing? S. Here's your S. XM over D. Oh, sorry. There's a D here. Can all sort out now? From here, I place my M equals to 2. I got this equation. Okay, now I'm using this one. Arc length. So the angle theta is just S divided by R. Right? S divided by R. So in this case, what is S? S is this one. Treat this D and this one D because this angle is very small. So these are two radius. Right? D is the radius. D. And XM. XM is this one. Take the D down. Then we get XM over D. So it's 2 lambda over D. And put in your value. That's your wavelength. That's your D. Okay, can or not? Answer C. Don't need this at all. If you want its path different, it's 2 long. But you don't need this at all. Okay, if you are all right, let's carry it to the next one. Okay, number 6. Which one is true about the slit separation? The distance D from slits to screen and the separation of fringes in Young's two-slit experiment. What's the answer? Always go to the formula to argue it out. Yep, what's the answer? Refer to your book, go to your textbook. If you don't have, there's a formula there, not a Young's double slit. Look at the formula and tell me the answer. But don't look at the answer. Yeah, this is the formula.
Oh, 1 minute. Okay.
Yeah, based on this formula.
A.
Okay, that's all. Use this formula. Lambda is constant. A. Okay, where A is unchanged, then your X is proportional to your, as your D increases, your X increases, your lambda is constant. You are just changing the A and D, that's all. Okay, A. Okay, number 7. Two polarizer P and Q. So P is your Q are arranged such that the angle between the axis of polarization is theta, the angle is theta. Intensity of beam of unpolarized light incident on the polarizer P is I naught. This is your starting point, I naught unpolarized light. Intensity of a beam that emerges from polarizer Q, almost the same as what we do. I call it I, but it's given as 0.2 I naught. So what's the answer? I think it's a repeat if I'm not mistaken. Yeah, since it's a repeat, you should be able to do the question. What's the answer? What is I1 in terms of I naught?
I1 equals to 0.20 I naught.
No. I1 in terms of I naught. I'm not asking you this one. This one is given there. Right? The final one coming I is given as that 0.2 I naught. But asking I1 in terms of I naught. Right? The polarizer cut off half of them. Yeah. So you must know straight away half I naught. Then after that, you can apply your Mahler's law for I1. Only after you pass through the one polarizer, then you can use Mahler's law. That's your Mahler's law. Right? You want I1 cos square theta. Then I take I1 across there. Take the square root, I got this one. And I, which is this one, is that value. I1 is this value. There. And I cancel off times 2 times 2. Yeah, we just done that. That's all. I think you're not paying attention in class. Don't know what you're doing. Okay, what is not clear? Anything that is not clear? Yep. Anything that's not clear? Ask. Whatever is not clear, ask.
Which the I is equals to I1 cos square theta, but then why not substitute cos square theta instead?
See what is happening is I naught passing through the polarizer P, half of it will be gone. That means I1 is half I naught. That's what we do. Then after that, we use Mahler's law. Mahler's law is only for this polarizer Q, where the one coming out I is I1 cos square theta. So I take I1 down, I take square root of it, I get this equation. Then I put in my I is this one. That's my I. I1 is this one, half I naught. I naught cancel off. I multiply by 2 here, multiply by 2 here. Then this one becomes 1. So it's 2 times 0.2, then square root 8. Can or not? Can or not? Can or not? Which one is still not clear?
Can.
If can, then let's go to the next one. If not, I will show you. Okay. A plane polarized light is passed through a polarizer. That's a polarizer. Right? This is polarized. So you can use Mahler's law. The polarizing axis is adjusted until the intensity of light produced is at its maximum value Imax. To what angle should the polarizer be further rotated so that the intensity of light becomes 20% of Imax? Yep. What is the answer? Yep. What is the answer?
Why?
Okay, let's see. Let this one be I. This one is passing through is I1. So if you adjust until maximum, then your Imax must be equals to I. Right? Because this is plane polarized, there's only one way to adjust it, where you will be the same value passing through I. And you use Mahler's law. Right? This is your I1 that we want to calculate. And I naught cos square theta. So in I naught, what is I naught? I naught is this one. That's I naught, which is equals to your I. Put it inside there. And take your I down. You get that, square root that. And put your value in I1. What is your I1? I1 you are told is 25% of Imax. So 25% is 0.25 Imax. And your I is your Imax. Okay, Imax and Imax cancel off. And use your calculator. Calculate 60 degrees. Sorry. C. Okay, anything not clear?
So far, okay.
Okay, let's go to the next one. The others you can do yourself. Let's try this one. Yeah.
The one the another slide you
Which one?
show back again. The one just discussed one.
This one.
Yeah. Okay. Regarding that, right, sir, the I1 0.25. How come 0.25? So the I naught is 0.25, is it?
25%? 25% is 0.25. 25% of that one. Okay, now. Anything else?
Then the I got Imax, the
I equals to Imax, there.
Oh, okay.
As long as you adjust, it cannot go higher than that. Right? You adjust it, the Imax must be equal to I. If you adjust it correctly, it means there is another polarizer here. The two must be the same parallel. Okay, which part is not clear? Okay, go to the next slide.
Mm.
Okay. Number 11. Right, we do one or two more. After that, we will go to take a 5 minutes break. After that, we will do the structure question. Break it into two videos, easier for you to revise. Which of the following produce a maximum separation of fringes in the Young's double slit? It's just repeating. We have done this before. Sorry, given you the answer. You don't know why I didn't remove the answer. Okay, basically, go to this formula. Right? And then remember, red light has a longer wavelength than green light. Which of the following will produce a maximum separation in fringes? So go to here. Green light 1 and 1. You want X is maximum. Right? This is your small d, this D. And you are only interested distance of screen, capital D. So lambda is the one that is here. So they are almost the same. So first thing to decide is red light, longer wavelength. Then after that, this is the smallest, this is the smallest, and then there's your D. The answer is A. Can or not? Which one is not clear?
So longer wavelength means
longer wavelength.
You can produce the maximum.
X larger, X larger, longer wavelength, X larger.
And then D is the
then you want the small
D.
Small D, the smallest. Small D, the smallest. So between these two, this is the smallest. Capital D is the longest. Right? The longer you can get, that's a capital D.
The better.
You can see the equation.
Okay.
Larger D, larger capital D, larger X. Okay. We try one more. And we take a break. We are getting too slow today. You can try the rest yourself. Don't know, you can ask me. Diffraction grating with 2,400 lines per cm is used to produce a diffraction pattern that is recorded by detector. The first order fringe is 8.94 cm from the central fringe. If the distance between the grating and the detector is 0.25 meter, what is the wavelength of the wave used? Okay. What's the answer?
C.
C, is it? Let's see. There's your D, donkey, that one. There's M equals 0, central maxima. That's the first maxima, M1, first order. And you are given first order fringe. This is your 0.84, that's your Y. Okay, so you use tangent. You are given D, you are given Y, can find the angle theta, Y over D. Okay, that's your Y, that's your D. Calculate out, get your theta. And use your diffraction grating formula. Sin theta is N M lambda. Okay, take your NM down. M down. Your N is 240 per cm. Okay, as long as we use the same unit. I use cm.
Sure.
Yeah.
Why not just continue? You got another like 10-15 minutes on each.
You prefer that way?
Yeah, I mean, and then plus half an hour.
Okay. We will do that. If you prefer that way, I thought breaking the video into two is easier for you to revise.
Easier, but then I can just like intervally I can stop and pause for a while.
Okay, okay, you prefer that way. Okay, I'm using all cm here. Okay, so I'm okay. I'm using cm. I don't have to convert it to meter for this one. That's your capital N. Right? M is 1, so I don't have to worry. Sorry. I'm using meter now. I'm using now 2,400 per cm. Per cm, I have to convert it, so I have to multiply by 100. Okay, good. You have got the right. Sorry, you got C. You said C, answer is B. Where did you go wrong again?
I think I double tick.
Cannot afford all this carelessness. Okay, let's choose some structure one. You can try the rest or not, you can ask me, no problem with that. State Huygens principle and use it to explain the action of diffraction grating. Okay, can remember Huygens principle?
Huygens principle states that point of wavefront emit in phase spherical wavelets that travel in the forward direction.
Right? Huygens principle states that point on the wavefront emit in phase spherical wavelet that travel in the forward direction. After a time t, the new wavefront is the surface that touches all the wavelets. Monochromatic light of frequency 5 times 10 to the power 14 Hz is at normal incident to the diffraction grating, which has 300 lines per millimeter. Determine the angle between the second order on both sides of the central maximum. Okay, what's the answer? Calculate out if you haven't done it yet.
No.
What's the answer? Isn't that what we just did? Sorry, I think you have to, they ask you, explain the action of diffraction grating. So you just have to state the Huygens principle. So when plane wave front is incident on the grating, each slit acts as a point source of light that are coherent. So constructive interference of wavelets from the slits give maximum, while destructive interference give minima in the other directions. Okay, not Huygens principle alone, but you have to explain because they want you to explain it in the context of diffraction grating. Right? Use this formula, that's all. Yeah, roughly I've drawn for you. The picture there. So your N is 300 is per millimeter. So we have to multiply by 10 to the power 3 to change it to meter per meter, this one. And M is also 2. Then we are given frequency. So this one is C. C, I better write down in case you are a bit lost. C equals to lambda F. That's what I'm using. Just I didn't show the step. So you are given frequency. So I'm using this formula. Lambda is C over F. So that's your C, that's your F. Then calculate out using calculator. And take the sine, take the inverse. I get 21.1 degree. Maximum number of maxima obtained. What is the answer? Yep. What is the answer? Yep. How should I do? What can I do? What should I do to get the answer? No idea. The maximum number of order. So this one, they sorry, haven't completed it. The angle between the second order maxima on both sides. So we have found this theta. Theta is this one. So you want 2 theta, this one. Sorry, you want this one. This we find theta 2 because this is second order. Theta 2 is this one. This is theta 2. So we want this angle, right, between these two second order. So that's why you have to multiply by 2. Same equation. Use this equation. Put this as 90 degrees. That's all. Yeah. So this 90 degrees. That's 90 degrees. Your n, take it to the other side. Lower lambda also down. So basically, I just playing with this formula. That's all. Right? The frequency now become on top. And this is your n there. Take it down. That's your speed of light. So you get 5.6 becomes 5. Okay. Anything that is not clear? Anything that is not clear? Talk to me. Which one you don't understand?
Teacher, the C value where is substituted, answer.
C? I want
C equals
lambda.
to pi f.
I want lambda. Right? So lambda is C over F. This is your C. This is your F.
Oh. Okay. Now why 2m plus 1, answer?
2m plus 1. This one you want to count all of them, no? But you want the maximum number of order. Maximum number of order is 5. Yeah? That's the equation that you need to remember. 2m plus 1. To count, because usually we didn't count the center one. So that's why we have to add 1 here. So m is the number of order. So in this case, it's 11, no? 5 on other side. And the center one. So it's 11, no? Okay?
Okay.
You need to review your work, right? If not, you are going to be in trouble. Let's try number 2. A ray of monochromatic light travels 70 millimeter in medium A of refractive index NA and 120 millimeter in medium B of refractive index NB, the path difference in the two media are equal. Calculate the ratio of NA over NB. Okay, what's the answer? This one testing you about path difference. Can or not? If not, I show you the answer. If you can, let it try out. Right? Remember the path difference. NL, N times L, refractive index times the length. So the path difference, I call path difference P lah. The path difference in medium A is 70, L is 70, NA. And for path difference in medium B, 120. As long as you use the same unit, all right, NB. And then you are told that the optical path difference is the same. Right? It's PA equals PB. Put in your value, 70 NA equals 120 NB. Right? Take your NB down, take your 70 down, you got that? So that's the answer. Can or not? Yep. Can or not? Can or not? Anything not clear?
Clear.
Okay, clear. Let's do one more before we go to do essay. Oh yeah, where I give you answer. Okay, a beam that consists of a mixture of unpolarized and plane polarized light is directed to a piece of polarized. It's a polarized. The maximum intensity is transmitted by polarized in 3 times the intensity. The maximum intensity transmitted by polarized is 3 times the minimum intensity transmitted. Okay, that's what I've given you. Calculate the ratio of the intensity of the plane polarized light to the unpolarized light. Okay, so roughly have either you draw it or have a rough idea what a picture in your mind. That is what is happening. Right? One is I, one is I naught. So call one of them polarized, unpolarized, one of them polarized. That's all. So can find the ratio. Right? Let I be unpolarized. This unpolarized. I know it's a polarized light. Okay. So how do you get maximum? This one is testing a lot of your application knowledge. It's a bit tough. Can or not? Can or not? If not, I will show you. I'll give you the answer. You want to try? I'll let you try. First, calculate how to get maximum from these two, how to get minimum from these two. So what is the maximum?
Three over two.
Right? Minimum means you cut off this one, no? And then half of this one will pass through. That's your minimum. When the polarizer is when polarized, right? When is removed, then polarized is half. That is when both polarized axes are perpendicular. What am I doing? When polarized, when the what am I doing? What am I doing? When polarized is removed and the unpolarized is half. That is when both polarizing axes are not understandable. This one. You are right. You give me 3 over 2. You are right. I'm trying to adjust this one. Very poor English. Okay. Maximum. I'll have to do it later on. Minimum is that. Uh, okay. The idea is when you pass both of that, one is unpolarized, one is polarized. You want it minimum, then you have to cut off this one. No? You adjust the polarizer until you cut off this one. This will be 0. And then this one will be half. That's why it's minimum here. And then after that, you are told maximum intensity transmitted by polarized is 3 times the minimum. That's why we get it from the question. This one. Okay. Then rewrite that. Take the minimum across there. That's what we get. Then replace I minimum. That one there. With this one, half I. That's what we get. So maximum occurs ratio of the intensity. So we have got the maximum and minimum. Maximum occur when the polarizer is I naught and unpolarized is half I. And both polarizing axes are parallel. Right? This one assume that there's another polarizer here. right? But I think this is unnecessary lah, right? Because you already told that. Maybe I should remove this one. Can understand? Can understand? Which part is not clear? I adjust this one until I cannot see this one. Then half of doesn't matter about this one unpolarized. Right? The polarizer will only allow half of it to go through. So no matter where you adjust it, it doesn't matter. Half of it will only pass through. So when you remove this one, half of it will only pass through. That's why we get minimum. Right? And then this one is obtained from here, from the question itself. So I want to find maximum is 3 times minimum. Then I'll replace that one, maximum 3 times. Right? Take the minimum across there and replace that minimum with this half. That's where I got half there, I. So maximum occur when polarizer is I naught, when the polarized is I naught, and the unpolarized is half I. Okay, that's all. 1.
Okay, that's all right.
Say again.
No, last question or what? This one.
We do one essay question, then we call that a day. And it can understand what's happening here. Maximum occur, we got I naught plus half I.
Why is it half I? Why not I only?
Maximum occur. Maximum occur, this one doesn't matter. Whatever angle you rotate through, it will just be half. That's what we get. So we adjust until this one I naught and I naught will pass through. That means if it's polarized, this axis and the previous polarizer that polarized this one has the same parallel axis. So this one must be maximum I naught. Yeah, then Imax is 3/2 I equals to that. Then I take my I across there. This becomes I. Okay, so this becomes I over I naught. So I over I naught equals to 1. Okay, which part is not clear?
Clear.
Clear. Let's go to do one essay question to show you how to answer. The rest you can try yourself.
I try myself.
I go over you. Question 1, no? Essay question. Yeah.
Okay.
State the conditions for interference to occur for light wave from 2 sources. Okay, what are the conditions? Yep. What are the conditions? Can you remember or not? Conditions for wave to interfere, both waves must be of the same type. Meet at a point. Yeah, that means wave of S1 and S2 must meet at a point. Same direction of polarization. Waves must be coherent and close together if it's for light. Right? You want light. So it must be close together and coherent. Okay, write down.
Okay.
Okay, so radio wave of frequency 110 megahertz are transmitted from two adjacent antenna, S1, S2 are your antenna, separated by a distance 2 meters. That distance is 2 meters. At the point P, destructive interference occur between the waves. Sorry, remove it. That's your point P. At point P, destructive interference occur between wave from S1 and S2. The angle theta is measured from the perpendicular bisector of the line joining the two antenna. What is the value of theta? Okay, can calculate. Basically, using Young's double slit, even though you apply to radio waves. Right? Write down, that's 2 meters. That's the angle theta. This also angle theta. That's your angle H. The angle theta is measured from the perpendicular bisector. That's the angle theta that we want of this angle. Right? That's your H. So you want destructive interference. That's the equation for destructive interference. Or that one there. Right? So point P is destructive interference occur between S1 and S2. So since they didn't say anything, we just assume it's the first one. Right? Half lambda. Okay, sine theta from here. Sine theta is that distance, body. Put in your value. Right? That's your path difference, half lambda over d. Put in your value, calculate your theta. Can or not? Anything not clear? Yep. What is not clear? Anything you don't understand? Here we assume m equals to 0, m equals to 1. Or half lambda, the first destructive interference, or the first minima. Which one is not clear? Ask, don't keep quiet.
Don't answer.
Okay, go ahead. Monochromatic light of wave. Sorry, what am I doing? Monochromatic light of wavelength lambda is a normal incident on a soft film of thickness T and reflective index N. Deduce the condition for destructive interference of light reflected on the film. Okay, this should be lambda, not theta. This one. This one should be lambda, not theta. Okay, what is the answer for C? For destructive interference, right? That's the path difference. And then there's a reflection of there's a change of phase from air to the boundary of the thin soap film. That's why we minus half. And then for destructive interference, that's why we get m equals 1 or 2. And then we can simplify. Take this one across there. Remove this one. We still got that. Okay or not? That's the answer. Let me just change the wavelength. That one should be wavelength lambda, not theta.
That's disgusting. What is flash? What does that mean? Flash it. Oh, she's happy.
Okay, that should be theta, not lambda. So sorry, that should be lambda, not theta. Sorry, I'm getting that already. Okay, that's the answer. Explain the principle of thin film in non-reflective lens. Derive the expression for the minimum thickness of the film in terms of lambda and reflective index n of the film. Can I explain? You want to try to explain for me before I give you the answer? Can or not? Cancellation or destructive interference of refracted light wave is utilized to make known reflective coating. The coating is put over glass and the coating material generally has a reflective index of refraction or reflective index less than that of glass. Right? So the reflection on the thin film, whether it's the top or the bottom, is 180 degrees out of phase. Right? In that case, then both reflected waves are 180 degrees out of phase. And the film thickness is a quarter lambda in the film to give half lambda. Okay. If not, write down. If you don't want to write this one, derive it. Coming down, T, going up T. So the path difference is 2T times your refractive index. And that must be, just using destructive interference, must be half lambda. Okay now. It's hard to teach you because you have not revising your work. But I teach you, you have forgotten already. So now you literally see stars. Yep. Anything not clear?
Roger.
Anything want to ask?
No, sir.
Okay, then we will stop here. You can try the other question.
See you next week,
You can
sir.
ask me. So next week, what day you want? Next week, what
I'll
day
tell you
want?
tomorrow, sir.
You tell me tomorrow.
I'll tell you
okay?
tomorrow.
You want another class tomorrow?
No. I tell you tomorrow.
Oh, you tell me tomorrow, okay?
Next
Okay,
week
I'll
I have
stop
online
here.
class already.
I'll stop here.
Okay.
Okay. See you next week.
Yeah, see you too, sir. I mean,
Yep.
2 months still can do a lot, right? Sir?
Say again.